Yo, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And this is the part 2 of shell sort sorting algorithm, where we are going to write a C++ program to implement the shell sort sorting. Now we've already discussed the overall working, the theory and the pseudocode. In fact, we completely dry run the pseudocode to understand how the algorithm works in the part 1 of shell sort. That is the previous video in this playlist itself. So if you want to understand the working, please watch that video. That is a very detailed video. But if you're here just to see the implementation, the practical side, that is the C++ program, then this video is just for you. Make sure you watch this till the end. And obviously I'm going to be sharing all the theory as well as this entire code on our official page. So if you're making notes, if you want to check this code on your system, just go to our official website. I will drop the link in the video description to this article where you can find all the information to shell sort sorting along with the C++ program. Okay, so with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. So starting off, as you can see on the screen, I have already opened up my Day C++ ID. Please get started with your ID as well. I would highly recommend that you guys type along with me for the best practice, especially if you're a beginner. And over here you can see I've already typed quite a lot of code, but that is all inside the main function, the int main, that is the execution point of a C++ program. And what we're doing over here is we are declaring the size, okay, and we're calling it n. So we say enter the size of the array, and then we take n from the user, then we create an array of that size. Now if you're using Turbo C++, this might not work with you because Dave C++ supports such dynamic creation of array with size which is taken from the runtime. But if that doesn't work, you can, for understanding purpose, hardcode this size, keep it 9 that we had in our, previous tutorial in part 1. I'll obviously put the entire algorithm also on the right hand side so you can see a black screen where we have the algorithm. But that's when we actually create the separate function of shell sort. Right now, we are inside the main function. So over here, we create an array 1 of that size that we pass. Then we say enter n integers in any order. So we run a for loop from 0 to I less than n. And we take all the input from the user in this array, that is ARR1. Okay. Then we say cout and we say before sorting. We call a for loop and we say cout ARR of 1. We run from 0 to n and we print out all the elements that are currently unsorted, that are not sorted, but that are there in the array as the output. Then we call shell sort. So we print out that shell sort is called over here, and then this is the function that we have to create. So this is the user defined function which we still have to create. We pass the array and we pass the size. So you can see in the algorithm also at the very top, the shell sort function is actually taking in an array and also the size of the array. So shell sort is called over here, and then again we say cout after sorting and again print out the same array. By the way, if you don't know, whenever you pass an array in a function in C++, it is passed by address. So whatever the array that is passed over here, all the changes will also happen in this array itself in that function. So it's one and the same thing. And if you don't know what is pass by address, pass by value, pass by reference, please make sure to watch a separate video that I have covered in the C++ playlist, which explains in detail these three concepts. It's kind of important. And yeah, this is where the int main function stops. So you can see return 0, this is the end. And now the only thing that we have to create is the shell sort function. If I just comment this out, save this, and if I say execute, compile and run, let's say our array size is 5. I'm going to enter some random values, 56, 54, 4, 3 and 2. If I hit enter right now before sorting and after sorting, the values are going to be same because shell sort function is still supposed to be created and called. So let's close this and now let's get started with the coding of shell sort function. If you want, you can just pause this video and type out this code yourself. I highly recommend that, or you can again visit our website and get this code. So starting off at the top, let's create this function. I'm going to say void because this function will not return anything. We'll say shell sort. Inside this we say int array, comma, int n is the size. You can also name the variable as size itself, but let's keep it n. You can see in the algorithm also it is n. Now if you see the algorithm, the first step, that is number 1, is the very first loop, that is the outer loop, which is gonna be calculating the gap at every iteration, and we're gonna calculate and use a formula where gap is always gonna be divided by 2 in every iteration. So the formula to calculate gap, that is the interval for shell sort, in our case is gonna be gap is equal to n by 2. So let's create this for loop. I'm gonna say int gap equals to n by 2. Okay, so that's the initialization. Then the condition over here has to be gap has to be greater than 0, obviously, because when gap becomes 0, we cannot compare the same element, right? So in shell sort, the idea is whatever the gap or interval is, we have to select 2 elements spaced in the array with that interval or gap value. So if the gap is 4, we have to select 2 elements which are spaced 4 positions from each other and compare them, and then you have to swap them, or you have to shift the values depending upon whether you're using insertion sort or bubble sort internally. Now in our example, we are using bubble sort, so we will compare 2 elements which are placed in the array with the distance of gap between them, and if the left element is larger, we will swap it with the smaller element to the right. Okay, so that's the whole idea. We've talked about it extensively in the part 1, so it might not make sense over here because there we saw it visually what was happening. But anyways, the condition is gap has to be greater than 0, and the decrement operation, that is at every iteration the gap has to be divided by 2, right? So this is how you write it, gap divide equal to 2. So this is nothing but gap is equal to gap by 2. Okay, this is how this operator works. So this is the for loop, that is the very first for loop, which will iteratively divide the gap by 2 till we reach 0. Okay, now once we come inside this for loop in the algorithm also, if you see, the step number 1.1 itself is another for loop which is gonna select, or which is gonna get the index position of that element in the array which is at a distance of gap, right? So that's where that j position is, and that's what we saw in the diagram also. So that for loop goes as follows. We say for j, that is int j equals to gap. The condition has to be j has to be less than n. So we will start from j and we will go till the end of the array, and then that's when the condition will become false, and then the for loop will again exit out. And since we have to go from j till n, we have to go one position ahead. We say j plus equal to 1, or you can also say j plus plus. So this is the second for loop which actually keeps a track of the j element which is at a distance of gap from the start, and then we move forward 1 element. And inside this, the first statement that we have in the algorithm itself is we create a temp variable. We say int temp equals to ARR of j. So whichever element that the j index position is pointing in the array, we first store it in a temporary variable, because now we have to compare this ARR of j with another element in the array which is at a distance of gap to the left from this position, from ARR of j, right? So first we'll store this ARR of j in the temp variable because we have to do the swapping. Then we say int I equals to 0. So we initialize a I variable outside the for loop, that is outside the third innermost for loop, because this I variable is also required in this for loop, that is in this j for loop at the end. So that's why we don't say for int I, because if we create a int I inside this for loop, it will only be functional, or it will only stay alive in this for loop. So once we exit outside this innermost third for loop, the I variable will be destroyed. That's what the scope of the variable is. So we want the scope of I variable to be existing in the second for loop and also the third for loop. So that's why we say I equals to 0 over here. And after this, if you see the algorithm, we have the third for loop where this I variable will again equal to be j. The condition is a composite condition where we have to say I greater than equal to gap. So this is one condition. Then we have a AND operator in between. So this is logical AND operator, which means that both the conditions need to be true. So this is the first condition, and then the second condition is ARR of I minus gap should be greater than temp. So ARR of I minus gap will select one element which is positioned to the left of the ARR of j in such a way that the position is at a distance of gap or at a distance of interval from ARR of j to the left. So we are comparing whether that element is greater than the ARR of j, because ARR of j is in temp, and if it is greater, then we have to do the swapping, right? So then we go inside the for loop But before that, we also have to give the decrement of the for loop, otherwise it will run infinitely. And the condition here is I minus equal to gap. So I minus equal to gap will ensure that we only compare and pick elements which are at a gap distance from each other in every pass. So if the gap is 4 and if we have 9 elements in the array, the last element will be compared with index position 4. The index position 4 will be compared with index position 0. That's how the comparison is going to happen at a distance of 4. So this I minus equal to gap ensures that kind of functionality. And we've again talked about this in working, because right now it might not make very sense, and hence it is very important that you first watch that video and only then this will be very easy. Now inside the for loop we have one statement. We say ARR of I is equal to ARR of I minus gap. So we take that leftmost element and put it in the rightmost element, and that rightmost element, remember, we had stored in temp, so don't worry, that is not going anywhere. So outside this for loop, when we come outside this for loop, we have one last statement which says ARR of I equals to temp. So that temporary variable now comes at the I position, because the I has now decremented by gap. Okay, so I over here is different and I over here value is going to be different, and the difference is always going to be of gap positions or interval positions, whatever you name this variable. And yeah, that's pretty much the entire algorithm for shell sort, and this should work. Let's save this and let's see if this works. Come down in the int main, and this is where you can see we've called that shell sort function the same name. Okay, we're passing ARR1 and n, which is the size, and then that's what is calculated over here. Let's save this and let's see if this works. Go to execute, compile and run. Okay, we did a silly mistake because we have to say square brackets over here when we create the shell sort function. Remember, when you're passing an array and when you're declaring or creating that function which takes in an array, in the arguments you have to add square brackets to denote that this variable is an array variable and not a simple variable. Okay, so I kind of forgot that. Anyways, execute, compile and run. Now things should work, and there you go, you can see things are working. So this is asking to enter the size of the array. If you've hard coded the size, then you just enter the array. Let's take our example that we saw in part 1. We'll enter the size of the array as 9, and we'll enter those same numbers that we had over there: 170, 75, 802, 90, 66, 224, 45 and 7. Let's hit enter, and there you go, you can see before sorting the same array is printed, but after sorting you can see shell sort is called over here, and we have 2, 7, 24, 45, 66, 75, 90, 170 and 802. So this is where shell sort is working perfectly fine. You can try out different variations, and we are getting our entire array sorted in proper ascending order. So yes, the practical implementation of writing a C++ program to implement shell sort is done, but one very important and extra thing that I wanted to show you over here is, in part 1 I had mentioned that shell sort works more efficiently compared to bubble sort or insertion sort, depending upon how it is implemented. In our case, shell sort kind of works as a bubble sort internally. So what we'll do is, let's write a bubble sort code also, and we'll compare shell sort versus bubble sort by tracking how many number of passes it is called. Now if it is not making sense, let me just put out the bubble sort code over here and I'll explain to you what is happening. Okay, so what I've done is I've kind of added one more variable in shell sort function. So in shell sort, I'm saying total number of passes. I've made it 0 initially, but at the end of every for loop, you can see this is the outermost for loop. It ends over here. At the end of this for loop, I have said total passes plus plus. So total passes will get incremented. Inside this for loop also, at the end, this is the last statement. Again, I've said total passes plus plus. And for the innermost third for loop, again I'm saying total passes plus plus. Okay. So this will count how many number of passes happens in the shell sort. And if I scroll up, I have actually copy pasted the bubble sort code from our bubble sort tutorial. We've already covered bubble sort, so you can see the article on bubble sort also. So I'm using that same code, and inside this also I have declared this total passes. So for the first for loop, the last statement is total passes plus plus. For the inner for loop, again total passes plus plus, and in the if block also I've said total passes plus plus. Okay, so this will keep a track of how many times the multiple loops are called and the internal if block is called. We can probably comment this out, but let's see how this works right now. And in the main function, what I'm going to do is I'm going to create one more array. So I'm going to say comma ARR2 with the same size of n, and I'm going to take input in ARR of 1, and I'm also gonna say ARR of 2 equals to ARR of 1. So ARR of 2 of I is gonna be ARR of 1 of I. So whatever values we take input in ARR 1 are gonna get copied to ARR of 2. Now before sorting, this is for shell sort, right? Then shell sort is called over here, then after sorting. So now let's copy this, and at the end we'll say bubble sort, and we'll call bubble sort now. So bubble sort, this is the function. We'll call it over here, and we'll again pass ARR of 2 and the size, and again print cout after sorting. Okay, so we've created two separate arrays in the int main. We've said ARR1 and ARR2, but both of them are of same size and holding the same values that are passed by the user. You can see this is that code, and the goal of this exercise over here is to see whether the shell sort takes less passes compared to bubble sort, right? So that's the whole idea. And in both bubble sort and shell sort, the last statement, you can see in the bubble sort, the last statement is cout total passes. So we'll print the bubble sort passes, and in shell sort also we are saying cout total passes, and we print out the total passes. So we'll see how many number of passes does shell sort take and bubble sort take to sort that same array with the same number of elements and same size of array. Okay, so let's save this and let's see if this works. I'm gonna say compile and run. Okay, things seem to be working fine. Let's enter the same array. I'm gonna say 9, and now it's saying enter 9 integers in any order. We'll say 170, 75, 802, 90, 66, 2, 24, 45 and 7. This is the same example. I'm gonna hit enter, and here you can see it is, the output is coming in one line, but you can see shell sort total passes 32, and after sorting we are getting the same sorted array. But in bubble sort you can see total passes 74, and after sorting we are getting the output. So let me just put this in the next line. So again inputting the value of size as 9 and all our integers. Now you can see before sorting we have the unsorted array, then shell sort is called, and the total number of passes shell sort is taking is 32. After sorting we have the sorted array. In bubble sort you can see total passes it is 74, which is kind of like almost double or more than double than what shell sort is taking, and we are getting the same sorted array. Let's comment out the internal if block total passes, because that's I guess not iterative. That is only called when ARR of j would be greater than ARR of j plus 1. But now still you can see shell sort is taking total passes of 32 and bubble sort is taking total passes 45. Even when we commented out total passes inside the if block of bubble sort, still the number of passes required by bubble sort is more than the number of passes required by shell sort for sorting the same array. Now this gets even more drastic when the number of integers in the array increases. So let's see how that goes. When I say execute, compile and run. Now let's enter a large sized array. Let's enter size of array as 15, and let's enter 15 integers. So I'm gonna enter this entire integers and I'm gonna hit enter. And now if you see, before sorting we have the unsorted array. In the shell sort it took 65 passes and we have the sorted array. But in bubble sort it is like 120, which is again almost double number of passes, and we've got the sorted array. Now let's enter one more large array with even more size, that is size 20. So this is that array. If I hit enter, you can see again shell sort is taking almost half number of passes compared to bubble sort, and hence now we can deduce that shell sort is much more efficient compared to bubble sort. And in our case shell sort is working even more better because the smaller values are towards the right and larger values are towards the left, and shell sort performs better in this case because we compare two elements which are at a distance of gap and do the swapping depending upon if the left element is larger than the right. And in our case the left element in most cases is going to be larger than the right? So that's the whole idea over here, and that's why it is performing much more efficiently. So yeah, this is something that I wanted to show you extra, and yeah, that's it for this video guys. I hope you liked this video and understood the implementation, the practical side of shell sort algorithm in the form of a C++ program. If you like this video, if you've watched this video so far, please hit the like button. Let me know in the comments how this video was. Do share it with your friends. Check out the article on shell sort. We've got all the details, theory, working, this code on our official website in that article. link in the video description, and I'll see you guys in the next video. Peace.